So we're going to pick up with last time, so 5.1 continued. In terms of the theory, didn't really do the theory, but in terms of what you need to know how to solve the problems, we pretty much did everything, so now we're just going to go through the examples, which you guys should have actually tried already. I believe this was the first example. Y equals x squared, the x-axis, and 0 to 2. How do we do it? Yeah.
I mean, you could draw it out first.
You can sketch it, sure. Y equals x squared, looks like this. The x-axis is that. Right. What's the equation of the x-axis?
Y equals 0.
That's y equals 0. Okay, so you have y equals x squared and y equals 0. Okay, so that's your x squared, y equals 0 is that, and we only care about between 0 and 2, which means you can kind of do this. So that's the area we care about. Okay, I want you to find the area between these two curves, and so what would that be? Yeah?
Integral 0 to 2, x squared dx.
Right, it's x squared minus 0 dx, right? And remember, that's, the idea comes from top minus bottom. Okay? This is the top and the bottom. So it's probably not super necessary for you to do this, but how I like to think of it, and it's useful in Calc 3 especially, if you can imagine yourself in a room. I like to imagine that, oh, if there's a little man trapped in here, I'm trapped in here, you know, and I look up and down, right, and top, that's the top to bottom, right, versus you can sometimes look right to left. If the region is complicated, you look up, down, and then you look right, left, and see which situation puts you in a simpler situation. I could have also looked left and right here, and I could have done it in a dy fashion, but that will actually be more work for me, because then I'd have to fix that, I'd get a radical y, and dealing with radicals more complicated. So it's much easier to do top and bottom. So then what? It's x cubed over 3 between 0 and 2, so that's 8 over 3. That's Calc 1. Okay. What was the second example? Y equals x squared and y equals x minus 2. So the area bounded by y equals, x equals y squared. And also y equals x minus 2. Okay, and you're not given any limits, which means you want to find the limits defined by the curves themselves. We can again sketch this out to try to see what we're looking for here. What does x equals y squared look like?
I have a question. How did you get the answer? 8 over 3.
Oh, I plugged the 2 into the x. 2 cubed is 8 over 3, plug the 0. Fundamental theorem of calculus. So it's 2 cubed over 3 minus 0 cubed over 3. Any other questions on this one before we move on? Okay. So what does y equals x equals y squared look like? It's a sideways problem, isn't it? So it'll look like this. That should pass through the origin. What does y equals x minus 2 look like? It's a straight line going like this. Going like this. Okay, give me some points it's going to pass through. How do I know where to draw it? Up here? Right, so remember that's going to be your y-intercept, so that's going to be a -2 right there. And by the way, this would be a 2. And so that's the region we care about. Okay, so how would you do this one? what's the first step? What would you do first? Yeah?
I set the equations equal to each other to find the intersection points.
Right, so we need to know what to integrate it between. 0 seems to be the obvious choice for 1, but we don't even know. And then, so I want to figure out what this point is. What is the x and y coordinate of that point? So the first thing we're going to want to do is to find intersections. How do we do that? How do we find the intersection? Yeah?
You have to equal the two equations.
That's one way to do it. When it comes to finding intersections, how you want to think about it is that you're plugging one into the other one. I know on paper it's equivalent to just setting two things equal to each other, but you really want to think of it as substituting one to the other. So I can take this guy and plug it in that guy, right? So x equals y squared, plug into other one, and I get y equals y squared minus 2. It would be the same as if you just said, oh, so x equals y plus 2, and then set the two x's equal to each other, you would get the same thing. But conceptually, you can get in trouble. Not really in this class, but in higher up classes, setting things equal to each other is probably not how you want to think about it. So we know for this guy, and now what?
Factor.
Factor that.
Can those factor? Let's try 2 and 1 seems to be what we should try. Minus 2 plus 1 seemed to work. And so we get y equals 2, y equals minus 1. So obviously this point here is, that gives us the minus 1. This point here gives us 2. Okay, so we found the intersection points. 2, now we're going to set up the integral. What do you do here?
Right curve minus left curve. Well, I did dy.
Why?
I don't really know, but it was because
Just felt like it, you just got a y here.
Yeah.
And like,
that's what I did, but yeah, I made my bounds. Cause like, wouldn't it work? All the curves.
Give me
would
something
match.
more concrete than that. Why not do dx? It's not going to be hard to do dx. I could have just plugged in y equals 2 here, and so I get my x value is 4. That's not going to be hard. And I could plug in y equals minus 1 here, and I get my x value is 1. So it's not hard finding the x numbers. Why did you choose to do it in terms of y? Yeah?
Because the function changed, so before x equals to 1, that's only the parabola, like, not the parabola, but x equals y squared. But after 1, that's including both functions.
Okay. So again, we're going to take this approach. Pretend we're stuck in the shaded region, right? And we're looking for the roof and the floor. Let's say you wanted to do dx and you're looking for top minus bottom. Okay, so here's your little man. He looks up, what's the roof? Well, it's this curve, which is the y squared. If he looks down, what's the floor? It's the line, y equals x minus 2. But is that always the case? What if you're standing over this side of the room? If you look up, what do you see?
Why?
That. If you look down, what do you see?
Same equation.
That, right? You notice that the floor switched. And because the floor switched, you need a whole new integral, a whole new top minus bottom, right? Now, if you do look at right, so we know immediately, so the top minus bottom, that guy would require 2 dos integrales. Is that Spanish for integrals? I don't know why I went that far. Yeah, integrals. Right? Because the bottom function changed. We had 2 different bottom functions. So I'm like, I don't want to do that. Maybe right minus left would be better. So now you check that with right minus left. If you look to the left, you see the parabola. You look to the right, you see the line. This guy down here, same situation. You'll notice that no matter where you are in this region, the left is always going to be the parabola. The right is always going to be the straight line. They're not going to switch on you. So it's better to do right. minus left here. So it's not good enough to say, oh, I chose to do dy because I happen to get my answers in terms of y here. Because I could have just as easily made it so that it'll be intuitive to get the x's here, and Jhevon is savvy enough to do that. So you don't want to just choose whatever hits you first. All right, so you really look at the area and examine what's better. Yeah?
So, would there be any cases where you do bottom minus top or left minus right?
No. Other questions? It's always top minus bottom, right minus left. One way you can also think of that is the area has to be positive, right? So if you're on a horizontal axis, the right is the bigger number, the left is the smaller number. That's the only way you'll get a positive. If you do left minus right, you get a negative number. Right? Your area between two curves is always going to be a positive answer. It's not exactly just an integral, it's a special kind of integral. It'll always be positive. Okay, so now that we know that, so right minus left means we're setting it up dy. And so in my integral, I should only have y's. My limits on the integral will come from y's. The functions I'm integrating should be functions of y. Okay, so what are your limits here?
-1 to 2.
Right, -1 up to 2. So it goes from here up to here. And we're going to do what?
Y
What's-
plus 2.
Y plus 2.
Y plus 2 minus.
Y squared.
Y squared.
So my functions have to be in terms of y. So this guy, y equals x minus 2, I have to write that as this. Right, just solve for the x. Okay, because I need the function of y. I'm doing dy. And so that's my right curve. This is my left curve. And from now on, it's just based back in Calc 1. So this, you integrated power rule, add 1 to the power, divide by the new power, comes 2y. This is y cubed over 3. And this is between minus 1 and 2. So you plug in the top number, 2 squared over 2 plus 2 times 2 minus 2 cubed over 3 minus parentheses, you plug in the bottom number. Minus 1 squared is just 1, plus 2 times minus 1 minus minus 1 cubed over 3. That's 2 plus 4 minus 8 over 3 minus a half plus 2 is be a plus minus 1. That's 2 plus 2 is 4 plus 4 is 8. That's 8. 8 over 3 minus 1 over 3 is 9 over 3. That's just 3. Minus a half. So that's 5 minus a half, which is what? Questions? Any questions? Third example. Y equals 3 minus x. Y equals x squared minus 9. Okay, what do we do here? You didn't sketch it? What does 3 minus x look like? Right, they'll pass through 3 and also 3 here. What about y squared minus 9? This is a parabola, right, it's positioned. It also passes through 3 here, so those are gonna touch. That's x through y. Here's shaded region. It's gonna go through a 9. It's gonna go through 3. So that's my picture. I want to find that area. So the little man trapped in the shaded region. If I look up, it's the line. If I look down, it's the parabola. That's literally true everywhere, so I probably go top minus bottom. Okay, what do I need to do to make that work? Yeah?
Find the intersection.
You need to find the intersections. That one's totally intersection, so I need to find this point, which at this point is obvious, that's 3, but at this point I don't know what that is. I need to find the x value for that point. And so I want to plug this y into that y, but it effectively comes down to actually just setting these two equal to each other. So I find intersection, which is 3 minus x equals x squared minus 9. This means I have x squared plus x is minus 12. Maybe 4 and 3. And those are negative, well, positive and minus. So either my x is minus 4 or my x is 3. This is obviously the 3, that would be the minus 4. And so now I'm going to set up the integral. So that means my area is going to be the integral from minus 4 up to 3 of the top curve, which is the line, 3 minus x, minus the bottom curve, which is the parabola, dx. Notice here that I'm using parentheses. So this is minus 4 up to 3 of 3 minus x squared plus 9. Okay, and here we do our integration rules. So the integral of 12 is 12x. Integral of x is x squared over 2. Integral of x squared is x cubed over 3. We're going to plug in 3 and minus 4. So this is going to be 12 times 3 minus 3 squared over 2 minus 3 cubed over 3 minus parentheses 12 times minus 4. And let's not waste time on the arithmetic. I really like to calculate this before. That was 343 over 6. So at this point, you'll be able to just use your calculator. If you like doing that in your head, that's fine. But the idea is much more important. Because literally, if you did all this, and let's say this problem is worth 10 points, and you get to here, and you're like, don't feel like it. I'll give you 9 out of the 10 points. And I don't like arithmetic myself. It's not like, oh, you didn't get the answer. I'm not, no. Usually, the answer to me on like a test, it's going to be 1 point out of all the points that I gave you. So you get up to here, I'm like, yeah, you know what you're doing. I'll give you 9. Maybe I might even give you 10 if I feel generous. Yeah.
So when you're setting up the integral, we did from the x points because we were doing x, but last time it was from the y points.
Oh, it's because the first thing you want to decide is whether you're going to do top minus bottom or right minus left. Top minus bottom is x.
Okay.
Right minus left is the y, so I'm figuring out which way is easier. Right minus left would not have been easier in this case, because if we look at the region that we were in, right? look, if you're a little man trapped up in here, if you look to your right, it's the line. Look to your left, it's the parabola. If you're trapped down here, if you look to your right, it's the parabola, right? See, there are two different functions on the right. So if I did right minus left, I would need two integrals. That was a lot more work. Top minus bottom was better. So that's what I chose. So before I even do anything, you're going to have to decide, should I be doing top minus bottom or right minus left? Do I want to think in terms of x or think in terms of y? You choose that from the very beginning. And that dictates what you do for the rest of the thing. Because for everything else, you need your answers in terms of x's. Your functions being x, your integral is x, your limits on your integral come from the x-axis, everything should be x once you make this choice. And in this case, it was the better choice to make because the other choice, I would need two integrals. My right function changed. Yeah, other questions?
So like the 12x minus x squared over 2, like is that the antiderivative of the function of like the equation?
Yeah, this here is antiderivative of this guy. Yes. Yeah, so that was the last part of Calc 1 where they did the fundamental theorem of calculus, how you can actually compute a definite integral to use the antiderivative and then plug in the limits. I don't know if your professor rushed through that or not. Everyone did Calc 1 here?
No.
No.
No, also, but you guys covered that? Like integration?
Yeah.
Like fundamental theorem? Okay. I'm going by the assumption that everyone covered that. I mean, once I actually set this up here, I'm assuming that everyone knows like this from the previous class. Right? The new thing is probably just this setup. Okay. Okay. Another example. Y equals x squared, y equals 2 minus x squared, and x is between 0 and 2. Okay, so we can sketch these. That's probably where I'd start. So one is x squared, and there's 2 minus x squared. Is that the region?
Yeah.
Is it?
No.
No.
Ish.
0 to 2.
Ish. Yeah, ish. Nice. Okay.
It's just the right.
Oh, just 0 to 2.
Is that the region?
You don't know if the intersect 2 to.
Yeah, we don't know for sure, right? What is that point? If that's 2, then yeah, that's the region. But is it 2? Let's find the intersection. So here we have 2x squared equals 2, so our x is actually going to be plus or minus 1. So the intersection here is minus 1, the intersection here is positive 1. So it actually, the region actually extends further. Just so it doesn't look completely awkward, let's go like that. So there's another piece over here that goes all the way up to 2. So things cross in this section. Okay. So now is the fateful question. Top minus bottom or right minus left?
Top minus bottom.
Why?
Because when you look up, it's 1 and then down. Don't you just have to flip it? You do have to like do top minus bottom, but then they
So-
use it for one region.
So in this case, the top is this, the bottom is that, but over
Yeah,
here,
it's the opposite.
it's that. But switching to right minus left, would that have been any better? No. Right minus left actually would have been worse. You'd end up with 4 integrals. And do you see why you'd end up with 4? Right? So top minus bottom, you have 2 integrals because there's a top and a bottom here, different from the top and the bottom here. But really, it's the same curves, just flipped. So you kind of use your answer from here to the answer there. But with right minus left, here the right and left are different from down here. And here the right and left are different from down here. So you end up with 4 integrals. 2 sections, but you need 2 integrals for each section. So in this case, top minus bottom is better. And because it's top minus bottom is better, x is my variable. Everything I do from now on is going to be in terms of x. So let's actually set it up. So we know here our area is going to be equal to, from 0 to 1, the guy on top is the 2 minus x squared, and I subtract the x squared. dx. Plus, from 1 up to 2, things actually switch. This becomes the x squared minus 2 minus x squared dx. One little trick, it might save you a few seconds, but it's probably worth it anyway. Just realize that this is just, the expression on the inside here is the negative of the expression here. So I could just factor out a negative sign, and my work will be essentially the same, but I put a minus in between. So I'm going to integrate this. That's 2x. This here will become 2x cubed over 3. That's between 0 and 1 minus pretty much the same thing. But this is going to be 1 up to 2. So you can write these out. This is 2 times 1 minus 2 times 1 cubed over 3 minus 0 minus 2 times 2 minus 2 times 2 cubed over 3 minus 2 times 1 minus 2 times 1 cubed over 3. And I think that'll simplify to 4. You can double check me on that, but when
It does.
I scribbled it, it simplified to 4. So algebraically, the work comes after you set up, but for the most part, I expect you to kind of be on autopilot in this region. Most of your brain power should really be deciding from the beginning, is it top minus bottom or right minus left, and how you set up the integrals, but after that, you should be in Calc 1 mode. Go to another example. But this question really illustrates that you can't always just go by the intersection points. If there's extra information given, you have to make sure that the answer you're given corresponds to what was required. So there was this extra piece of area here that we have to figure out. Y equals x squared, y equals 2 minus x, y equals 0. Let's graph that. Y equals x squared, y equals 2 minus x, x. Okay, what's the region that we care about here? Jessica?
Should it be after y equals 0? It's not a bound.
That's not the area. Why is that not the area?
Y equals 0?
because that's not bounded by y equals 0. If I look at this guy, the bounds are just these two curves. It needs to be bounded by three things, okay? So let's try again. This line is one of the boundaries that I want. So it turns out this is going to be the area. I'm going to be bounded by x squared, 2 minus x, and y equals 0. So you need to pick the region that satisfies the requirements, right? I need to be bounded by three things. If I was over here, I'm only bounded by two of them. That's something you have to be very careful for. It'll cause you a lot of trouble here, but if you're unfamiliar with how to bound things in Calc 3, it's going to be a nightmare. You have no idea the kind of chaos a mistake like that can make. Okay, so yeah, so this is our region here. So now the fateful question, top or bottom, or right and left? What do you think?
Right and left.
Right.
Why?
Because then you'd have to change.
You don't have to change. If you're over here, top and bottom are different, right? The top is the parabola, the bottom is the x-axis. If you're over here though, the top is the line and the bottom is the x-axis. You see that? So the top and bottom switched on you, which would require a whole other integral. However, everywhere along this shaded region, the left is always the parabola and the right is always the line. So right minus left is easier here. Which means everything is going to be done in terms of y's. My limits should come from the y-axis. My curve should be written as functions of y. And so, well, 2 minus x, well, I have to find the intersections, right? So it's easy to see that one of these intersections is y equals 0, right? But the other one, I need to find that number, right? And that number comes from where? How do I find that number?
The first two equations.
Right, it's the intersection of only the first two equations. So it's the intersection of y equals x squared and y equals 2 minus x. And so that's going to be x squared equals 2 minus x, and so x squared plus x minus 2 equals 0. And we would have 2 and 1 plus 2 minus 1. So my x can be minus 2, or my x can be 1. So clearly this would happen at x equals 1. So x equals 1 would mean that my y is also 1. So I know I'm going between 0 and 1 on the limits. So now I'm going to set up that integral. My area is going to be the integral from 0 to 1 of the function on the right, which is going to be this guy, the straight line, which I have to write in terms of y's. So I'm going to actually think of this as x equals 2 minus y. That's going to be 2 minus y minus guy on the left, which I have to think of that as a function of y, so I'm going to think of this as x equals the square root of y. This side would be the negative square root of y, so I'm just going to so that's my integral. This guy, because we want to use the formulas for integration, I'd have to write that as a power, so that's y to the half. So now I find the antiderivative. Integral of 2 is 2y minus y squared over 2 minus y to the 3 over 2 times 2 thirds. That's between 0 and 1. So the 0 is going to kill everything, so it's just going to be the 1. And what was that? I think that's maybe 5 or 6. Right, the LCD is going to be 6, so this would be 12 over 6 minus 3 over 6 minus 6 over 6. Any questions on that? I feel like it would have been very common in this particular problem to mess up from the very beginning, actually figuring out that was the area that you were after. Probably would have caught a lot of you, I'm not sure. So these problems, you really have to be careful about the setups and really know, am I looking at the right area? And then figuring out, should I be doing right minus left or top minus bottom? Let's actually sketch this one. So we did this already, so that's x equals y squared, looks like that. X equals 2 minus y would look like that. The intersections here are going to be y equals plus or minus 1, because we did something similar to that in the previous problem. So technically you would have written it all out, but it's similar to D. Right, so in D we had y equals x squared and y equals 2 minus x squared, and we found the intersection is going to be the same except in terms of y here. So y is going to be plus or minus 1. What do we want to do here? Top minus bottom or right minus left? Right minus left is better, right? You're trapped in here, look to your left, it's always that curve, look to your right, it's always that curve. However, on this side, the top and bottom are different from the top and bottom on that side. Right, so if you're thinking in terms of x, the room splits in 2, and your roof and floor changes. Okay, so right minus left is actually the better route to do this. Right minus left, dy. So I would actually do minus 1 to 1. And there's shortcuts with this one. I could have done something like 0 to 1 and double the answer, but maybe we'll talk a bit more about that later. What's my curve on the right side? It's this guy. So it's 2 minus y squared minus my curve on the left side is just y squared.
You can simplify that.
Yep. So it's 2 minus 2y squared, 2 minus 1 and 1 dy. 2y minus 2/3 y cubed. 2 minus 1 and 1. Actually, I think I will use the symmetry because I don't particularly like arithmetic. So this is 2 times 2y minus 2/3 y cubed between 0 and 1. Talk about that. There are some things called even functions where if you're going between integrating on a balanced interval, it's just double half the interval. This is when you have symmetry about the y-axis. Okay, you call such functions even. So if it's on both sides, they look exactly the same. It also means that f of minus x is equal to f of x. Okay? So if you have a function that has that property, or you can see the graph is entirely symmetric about the y-axis, you can actually do this trick. There's another one, by the way, if your f is odd, then integral from minus a to a of f of x dx is actually always 0. So this means your f of minus x is actually minus f of x. And so pictorially what that would mean is that one side here is literally the opposite of the negative side on the other side. So. Anyway, so that's what I'm using here to change this to 0 because it's entirely symmetric. It's entirely symmetric. Right? So I replace y with minus y, I get exactly the same thing. Okay, that being said, let's move on. So this is then going to be 2 minus 2/3. Plug in zeros, everything dies. So 2 times 2 I can think of as 6 over 3 minus 3 over 3 is as 4 over 3. That's again 8. Yes.
Wait, why is the interval to -1 to 1?
Those are the bounds. This intersection point is -1, that intersection point is 1. You found it? So that question that I asked you before, do we have to sketch? I started all of these with a picture. Was that necessary? Can you think of another way to figure out who's top and bottom or right and left? Let's do the 3 minus x and the x squared minus 9. We sort of had this thing happening, so we have 3 minus x squared minus 9. What is that? Is that phone? I don't think it's my phone, it's on silent. Okay, so we found the intersections before. What were they? It was 3 and was it -4? So let's say you found those intersections, right? So then we know that the intersections, we know that it's x equals 3 and x equals -4. How could you figure out who's on top and who's on bottom? As in, pretend we didn't do this. Was there another way? Yeah?
I mean, assuming that the two functions are continuous, you could pick a simple value of x between the two intersection points and just evaluate which one is greater.
Yeah, exactly. So we're on the number line here. There's a -4 and there's a 3. And I know I only care about what's in the middle. Just plug in a number in the middle. Plug in an easy number, like 0, for example. So if I take y1 is equal to 3 minus x, this means at the point 0, it will give me a value of 3. And if I take y2 as the other function, which is x squared minus 9, if I plug in 0, that will give me a value of -9. This guy is larger. So that's the top. Right, you can literally just plug in the x values. So if you end up in a situation where I'm not quite sure how to sketch it, find all your intersection points, examine the region that you're supposed to be in, and just plug in individual numbers in each interval. Okay, so that would have told you it's the top. intuitive reasons though, I will mention that it's highly preferable for you to know how to sketch things. It'll actually make your life a lot easier in the long run, as well as here. Just know how to sketch things. There might be times where I might even require you to sketch it, so you never know. But if I don't require it, or even if I do require it, but I don't remember how to sketch that function, technically you don't have to. It's better that you lose some of the points for the sketch, but you get everything else you should know about different options. And that's one of the things you're going to want to do, be able to do in this class, and pretty much every math class. There's no several options to get to the same thing, because if you're ever in a test and you're freaking out or you forget something, you can stay calm because you go, oh, I have many options to do this thing. I can just pick another one that I remember. So we'll stop there. So we finished this section, so the homework for this section is due on Tuesday, and we'll also have a quiz next week. So we'll stop there if there are no questions. Yeah.
Do you return quizzes?
Yes, I will return the quiz. So I'll return the worst next week.
The quiz will be on what this is, right?
Quiz will be on everything we've covered so far. But 5.1 is all we covered, so everything from 5.1. Yeah.
So could you put the questions for homework?
They're already there.
Oh.
So if you go to my website, the first 5 sections of the textbook are there in case you're having trouble getting your textbook. The syllabus is there, and the video lectures, link to the lectures are also there. So you should have everything. Thank you. We'll see. All right, later.